Thanks very much, Seb. I'm going to talk now on developing and evaluating ecosystem essential ocean variables for SOOS. Much of this talk is going to be reporting on outcomes from a workshop that was hosted last year at Rutgers University. Oscar kindly hosted the workshop, and on behalf of Oscar, Dan, Louise, Ed Urban, who unfortunately was unable to be here, and me, we organised this workshop to try and look at what would constitute ecosystem essential ocean variables in the context of the framework on ocean observing, and really how much progress have we made. One of the things that Seb indicates is that biology is underdeveloped, and it's quite often reported as being underdeveloped. But I would argue from the outcomes of that workshop that that's far from the case. It's actually well developed. I suspect that it's not well consolidated in the same way that it is consolidated for the physical and the chemical sciences. And so I thought the Rutgers workshop was a great way of beginning that consolidation and seeing how we might take that forward. So that's what I'm wanting to talk about today. And I particularly want to talk about it in the context of this workshop. What would we like to see at the end of the workshop in developing the ecosystem side of SOOS? And so we thought about that in relation to theme 6, which is biology, but there are a lot of other parts of what we talked about that have relevance to the other themes. So I'd like us to think more broadly about the ecosystem in the way that was described by Jess last night, and to start to think about what would we measure and how would we use those measurements. And this is coming up all the time, how would you use that? So we look at the Southern Ocean, as you can see on the screens. Often when we talk about the state, and we think about it as a map, just like we have behind us, but we know with respect to ecosystems that it's actually n-dimensional. And we have this emerging properties of biology which aren't confined to the spatial and temporal scales of the physics and the chemistry. They can range across those scales in many varied ways, and also ranging across those scales with each other. That's one of the challenges that we have. The biogeochemists are already familiar with many of those challenges, and with recent studies, we would argue that higher trophic levels could have an impact on these kinds of activities at the lower trophic level. So how do we actually collapse that into something manageable in the Southern Ocean observing system? So one of the products of the workshop was to identify that there are a number of ecosystem properties that most people want to know about. And so we tried to characterise that in this diagram, where there's a number of pressures, global pressures, climate change, ocean acidification and so on. There's regional human pressures like fisheries, tourism, pollution and coastal activities, not necessarily relevant in Antarctica, but nevertheless there. And they put pressure on the biological systems in various ways. It's not just a bottom-up process, there's top-down processes as well. So fisheries have a top-down impact on the system and so on. And we try to characterise these relationships in this fairly basic way, which is you have the physical and chemical environment. It helps form habitat, but there is also biogenic habitat, so biota actually can influence habitats. Then we have the species pool, the diversity that is going to utilise those habitats, and the habitat and diversity combined give us the food web or the trophic dynamics. And we can have all sorts of interactions. I'm not going to go into it any further here, but we're trying to collapse what is a fairly complex system into some way of thinking about how we might observe that. So what I want to do in this talk is actually step through a process. The process of design is more or less the process of trying to say, how can we deliver good advice? We've heard already, a number of people have said, what's the question? What's the purpose of the observing system? What are the variables that we wish to measure? How are we going to implement a system to measure those variables in a way that gives us good information? And the way we've talked about it already is to get good signal to noise ratios, to reduce the amount of error and so on. How are we going to use those measures in assessments that allow us to make statements about the system? And then how do we provide quality advice? And we can see in that process that it's actually not a linear process. because we need to know about what kinds of qualities we need to have in our advice in order to clarify our purpose, therefore in order to design the variables and so on. And so we saw that it is a fairly dynamic system. It's not something we can at this workshop say, these are the variables, and then everything flows from there. It's something that we're going to have as a dynamic system. So what I'd like to do is to cover the purpose and the challenges, to think about the things that we talked about at the Rutgers workshop. I want to talk particularly about a framework that we developed at the workshop that made sense to us, and how might we use that framework then to develop what would be the essential ecosystem variables. We also talked a little bit about implementation, and then that's something that needs further development. And I'll go through some of the conversations that we had, and I think Matt's going to talk a lot about what we were talking about in terms of then the design and the implementing of the system. And then I want to talk about some of the milestones that we might consider. Now, these are post-workshop musings. This is something that I think would be worthwhile talking about at this meeting, because as Steve has indicated, we have made progress. We're not reporting well on the progress, but we've got very clear steps that we have taken. And through that conversation, we've also got very strong ideas about what the next steps are. And I think it would be really good by the end of this workshop to have those steps well consolidated and identify groups that can take those forward. And those groups may not necessarily be here. I think when we're talking about who's going to take these tasks on, you can freely nominate people that aren't here. So just think like that, how are we going to assemble the community to give effect to these things? That's going to be one of the questions. You don't have to feel like you have to take everything on. Of course, people that aren't here can always say no, but at least we can get the conversation going. So what might the purpose be? And here what I want to do is just to try to draw out a little about a framework about what we're trying to do and how are we going to deliver that to people that need the information. SOOS is designed as an observing system that provides a foundation for science, provides a foundation for policy and management and so on. So the diagram on the screen is something that has evolved over time, but down the bottom you'll see that there's two boxes, status and trends and the future states. In our conversation in the Southern Ocean, quite often we're talking about the effects of climate change and how understanding the effects of climate change on the Southern Ocean and the effects of the Southern Ocean on the climate, how that might feed into discussions in the IPCC and so forth. In my space, I work a lot in CAMELA, not just in the IPCC space. So CAMELA, the Commission for the Conservation of Antarctic Marine Living Resources, needs information from the Southern Ocean to help manage fisheries, to help achieve conservation outcomes, and to also make decisions about how things might be managed into the future. The same is true in the Committee of Environmental Protection, the CEP, which is part of the Antarctic Treaty Consultative meeting. There's also ACAP, the Agreement on the Conservation of Albatross and Petrels, and the International Whaling Commission. These bodies need that information to make decisions, and that's a different role to what the IPCC has. So how do we actually frame the Southern Ocean Observing System to facilitate those two things? And the higher level boxes there, the orange boxes, are those which are ultimately the outcomes that we're trying to achieve. So if we want to see a direction for SOOS and having an impact, how does it impact on that system? And it's at that lower level. How might SOOS facilitate statements on status and trends and on future states? And as Nathan brings up, on attribution as well. So we have that layer as well. So this is where we might see science feeding into status and trends and future state statements. We need assessment methods. We need models. So they're two elements that we have. And we've talked about maybe having a modelling working group to help SOOS. We also know, and this is where SOOS is, we need regional observations, and that's our big gap for the Southern Ocean. But we also need process studies to help make sense of the system, and then that facilitates the attribution question. And then there's the design questions. And a lot of our discussions have been at the design level on field designs and modelling designs. So where does SOOS fit in? In a biological sense, there are two large groups that have been set up that are trying to integrate the community. There's SOOS, and there's also another program integrating climate and ecosystem dynamics, which is part of IMBA, but also part of SCAR. And I haven't put the SCAR logo on here, but SCAR is also part of assembling that information. There are a number of groups within SCAR that are doing this kind of work, wishing to utilise this information, but also developing that information. And so, if you like, SCAR cuts across SOOS and ICE. It's one of the primary sponsors of both of those groups. The reason why I put this up is that I thought it was reasonably important to try to articulate what SOOS is trying to achieve as opposed to what other bodies are trying to achieve, rather than trying to duplicate what those other bodies are. So SOOS has an observation role that can feed into the modelling and assessment role. Of course, there's going to be an interaction. There's going to be a need for joint discussions and so on. There will be a need for discussions with other bodies, such as the Scientific Committee of Camelot. But nevertheless, we can see a role then for SOOS in this system. So what are our challenges then, if we're trying to have SOOS provide effective input to these other bodies, science bodies and policy and so on? In assessing status, trends, attribution, and also being able to talk about the future, one of our big challenges is what variables we do measure. We've talked about that. We have, as Joellen says, there'll be variables we'd love to measure, but we can't right now. And then there are other variables which we can measure, but we don't know whether or not they're really going to have an effect. And there was a discussion yesterday about that. It all depends on your focus. And I put these diagrams up just to illustrate how focus can influence the way we make choices. And we need to start thinking about that, particularly in the biological space, so as we don't expend a lot of energy. So on the left-hand side, you'll see if you're solely interested in the krill fishery, measuring krill is probably of primary importance and not much else. If you know how much is there and what krill does, then just keep track of that and you can manage your fishery. In Camelot, there's also a requirement to have the ecosystem approach to take account of krill predators and other things to do with the conservation of the system. And so we can put obligate krill predators there, which adds our complexity already. I'm not going to stop there, of course. One of the things that we know in the Southern Ocean is that you can have transitions between a krill-based food web to a fish or copepod and fish-based food web. And that's what I illustrate here on the bottom right. That adds another sense of complexity as you start to add that detail, and then you start to see crossover between those different components. And if we're interested in the carbon export questions as well, then the system becomes quite complicated. And then on top of that, you have to take account of the space and time scales and the interactions between them and so on. So for biology, we are trying to deal with a reasonably complicated system, as I started out with, but how do we make order within that? The Rutgers workshop actually made a lot of progress in trying to develop some order in what you would choose to measure, so as those with different foci can do their work. So as we don't have to tailor it to one community or another community, but we try to come up with foundation variables that are important to most, if not all, communities. The second challenge that we face is that how do we deal with trying to develop ecosystem observing when we're dealing with multinational, multidisciplinary, multi-platform programs. I'm putting up a map here of a program we're pulling together for next summer, and you can see here there'll be 5 vessels involved doing different things because of their own priorities, but trying to look at how do we integrate all of those observations so as we can make sense of, in this case, the Kerguelen axis area. What's interesting about these discussions is that this is the foundation of SOOS. How do we actually bring together all of these different platforms and programs so as we have data streams that can be knitted together to give effect to some of the analyses that we want to do? So how are we going to achieve that? And then the third challenge is how do we provide data sets that are really going to provide the foundation for delivering quality advice? How might we partition our activities? And we've talked about that as regional working groups, but also how do we start to deliver data which is going to be most important for assessments or for other purposes. So starting to articulate those pathways from data to impact is going to be quite important in this process. So I'd like to move in, having talked about purpose and challenges, how did we start to grapple with the issue of developing ecosystem essential ocean variables? There are 3 questions that we tried to cover. Well, what is an EEOV? what are the stages in developing EEOVs within the context of the Framework on Ocean Observing, and importantly, what might be the criteria for prioritising EEOVs. When we think about stages in development and those criteria, we can actually start to see that there is a home in the conversations in SOOS to deal with. We'd love to have them. We know they're important, but we can't quite do them yet. There is a place to actually put those on a list and work on them, as well as just having mature variables, which we know we're monitoring all the time. So how do we actually start to generate that list, give a sense of priority to them, and something that we can then work on to the future? Now, one of the things that was raised with me in the break, and it was certainly, I think, one of the major outcomes of the Rutgers workshop, is that use of terms matter. We need to actually understand what we mean when we're using these terms. And in developing the manuscript, which I have here, which hopefully will be submitted in weeks from the workshop, trying to have a common understanding to the usage of terms really did make a difference to being able to progress the workshop, but then to progress the manuscript. And I don't think that we've bottomed out yet, and I think others are still grappling with that. So what is an ecosystem essential ocean variable? Firstly, the term essential is something that essential ocean variable, or EOV, is something we've adopted from the FOO. We seem to sometimes get stuck on the term essential. Really, it's about getting a sense of priority between the variables. This diagram here is something that we came up with towards the end of the workshop when we tried to understand what was the scale of an EOV. So as we would understand, if somebody was wanting to propose an EOV, what are the sorts of properties that they would consider important in proposing such a variable? We had a number of points in this discussion, but clearly at the top, we were looking for being able to use the data to be able to make some assessments of status, trends, attribution, and some statements about prognoses or predictions for the future. There are a number of levels below that that might contribute to such statements, knowing about the ecosystem properties, habitat, diversity, trophic function, primary production. Those are the sorts of things we consider to be ecosystem properties. We'd use a lot of different kinds of data in order to deliver assessments of those properties. So we didn't see those properties themselves were EEOVs, they were the product of a number of EEOVs. We need assessment methods that help bring together, knit together, or give us fusion of the data to be able to make assessments of those properties, and there we have EEOVs. And I think taking account of Sir Guy's comment from before about new technologies, the rapid evolution, the recognition that I would say even in 5 years' time, the world will be very different in terms of its observational capacity. So EEOVs is above that level to allow for that sort of activity to happen. The field measurements is where there will be a lot of dynamism, and that's one of the things that we've talked about in terms of technical working groups. How can we embrace and also force or push for new technologies? So we saw then we need to have field measurements that we will then transform in some way into our EEOVs, and then from there we will have assessments. On the right-hand side, you'll see that there is a range there in a krill example running from an acoustic transect or an acoustic signature through to an estimate of krill density and so on. Now, some of the discussions that will be had is whether or not you even need some of those transformations. There is some work going on which is looking at, can you use signatures in their raw form to be able to utilise that in being able to develop models and so on. And it may be that over time the signatures will become the EEOVs rather than trying to estimate something from those signatures in an interim step. So what are the stages in developing the EEOVs? On the left-hand side, you'll see that structure that we had in the pyramid. We have an observing system that are delivering data, the field measurements that give us then the EEOVs. We have the assessment methods that tell us about the ecosystem properties, and the estimates of those properties then allow us to address the policy-oriented questions. We could generate EEOVs at a base level because we recognise the system is short of variables that we need, or the EEOVs might be determined from policy-oriented questions. So there are different ways that you can come up with proposals and demonstrated need. But once you have a demonstrable need for an EEOV, then clearly we need some idea about how does that fit in conceptually with what we're trying to achieve. We need some form of proof of concept of observations. And then once we've got an idea that conceptually it is sound, then it becomes a conceptual EEOV. And then we're on the path that the Framework on Ocean Observing has indicated. You can see here that it's possible that we could easily review many of the measurements we make already and see that they are conceptually well-founded, and they may even be at the pilot level. So to get to the pilot level, we need to have some idea of a sampling strategy has been verified. In other words, how would you go about collecting it? What would be the standard method to give you the field observations? And can you generate some commitment to achieving it? In other words, we start to talk about the concept of feasibility. Can you actually take it out in the field and start demonstrating that observations can begin coming? And we need some data management practices associated with that. There are already some well-founded programs that are dealing with that. So, for example, there was a recent meeting looking at the consolidation of penguin tracks in the Southern Ocean. There's been an excellent program of work with elephant seals, seal tracking, penguin tracking and so on. All of that's being consolidated. The methods are well founded. That could easily be developed through to the pilot stage. And there are many others as well. How do you take it then to a mature stage? Again, for something like the elephant seal tracking, that is circum-Antarctic, it's well covered, and I would argue it's probably at the mature stage. But how do we demonstrate that? So we need to validate the measurements, and we can have standard methods and so on. We need to be able to have some peer review process that says that, yes, this is possible, it's possible to do it indefinitely, and we can have data streams that are well managed. So that's one particular case that has been developed. While SOOS has been developing, it's being developed outside of the SOOS framework, but readily meets the SOOS framework. And you can see there that it would be possible, as Joellen has argued, it's possible to say, we've got this idea, we think that it's really important, the models tell us that it's important, the need is demonstrated. How would you then go out and measure it? That may be where it falls over. So the need's demonstrated, and then a task group could be set up to start to review that and start to insert this into the process. And if you look at the template that Seb was introducing earlier, you can start to fill in the boxes, but you may not get very far. But you can see then how the program of work would continue and to start to see the development of an EEOV or an EOV over time. So it can be dynamic, and we can enter at very many levels. So what are the criteria that we might use for EEOVs? We came up with 9. There are a number of criteria around in the scientific community about how you would, or what's important for an indicator. One of the things to think about with an indicator is that it's trying to demonstrate that something has changed. In the discussion at the Rutgers workshop, we also recognised that measuring some variables is going to be important to be able to give strong foundation to models. Even though they may not change significantly over the time, they may be able to ground the models well. And so having that extra role for EEOVs is something that's not just signalling change, but also contributing to models. So there are 2 criteria that are quite important in thinking about what an EEOV might be. How might it contribute to understanding of policymakers and the public in understanding the Southern Ocean system? Again, it may be useful to measure things that routinely, that aren't necessarily something that would signal change, but help in that process. Another factor is what alignment does a particular variable have with other EEOVs? Is there a suite of variables that need to be measured together in order to make sense of something? We need to be able to understand that. And something about alignment is the historical data sets. I liked the talks yesterday afternoon, which were talking about how do you knit together the historical data sets, which are very patchy in space and time, and how do you make use of those in the context of the data streams that we now have. So having EEOVs that help that knitting process would be a good thing. And it may be that they don't need to run for very long, but just enough to be able to knit the variables together, and therefore allow us to look better at the ecosystems in the past, which at the moment we currently don't have a good capacity to do. So Guy's point again, is there potential for them to be adapted over time, or are they quite fixed? Could they potentially become redundant? Another point which comes down to feasibility is, can they be sampled at appropriate space and time scales? Now, one of the important points about that is that not all variables need to be measured at the same time and in the same place. You may be able to measure a population only once every few years, and that would be effective. And other things like primary production, you have to be measuring the variables every year or even seasonally or monthly. Depending on the temporal and spatial qualities in the data, we need to make those decisions. But it's certainly not important that once we've got a list of EEOVs, that has to be on the framework of every platform that's going into the Southern Ocean every year. We've talked about high signal-to-noise ratio. That's going to be an important part of this. And then one of the things too is that some EEOVs may have great potential to enable adaptive sampling. And what that might be, I'll go in during the workshop if we need to. So the second stage then is, well, what sort of candidates might there be for the Southern Ocean once we start to apply that framework? This is the simple system that might be applied if we're looking at the effects of, potential effects of fishing for krill on penguins. We would want to know about the abundance of krill, the catch of the fishery, and then some attributes of the performance of the penguins. We can start to tease out what those essential variables might be. If we want to look at the context of global and regional change and what impact that might have on the fishing system, you can see in the centre there, there's still the krill fishery penguin system, but you can see all the other variables that we might need to measure. The ellipses there, those things which is the fish-based system, which may be important in considering tipping points and so on, we may not need to be measuring those directly to anchor our models well. It may be that monitoring elephant seals would be sufficient to anchor that part of the food web. It may not be too, but that's a consideration that would be worthwhile having. I'd like to raise here too that the potential for using signatures such as size spectra, isotopes, genetics, acoustics, foraging pattern signatures, those things may well be, as I indicated before, EEOVs, rather than having to measure everything in detail. In the end, we came up with 87 candidate EEOVs. That's not the short list of temperature, salinity, depth. How are we going to tease out what's important in 87? We have a table here. I'm not going to go through that in detail, but it does range from habitat variables to some idea of the types of organisms there and their relative abundance, then through to the trophic linkages, such as through diet, foraging patterns and the like. So there's a variety of things there, and it will increase in the complexity of variables as we move up the trophic scale. So we need a process then for working out what the essential ones are. The Southern Ocean actually provides us with a great opportunity to try and tease out some of those things. There are regional differences as we go around the Southern Ocean between the Atlantic sector, the Indian sector, the West Pacific, the West Antarctic Peninsula. Differences in the prognoses for the physical environment, differences in the behaviours of species and so on. So we can start to use that to advantage in trying to tease out what's important. It may be that measuring a few things in all places may give us an idea then about how the important processes are working and then better ground our models. One of the things that's shown in this slide is that if we look at top predators with ellipses on the map in yellow, we look at monitoring of krill in red, and in monitoring of the primary producers in blue, you'll see that we don't actually overlay our observations very much. And this is the point right from the beginning. We know a lot about what to do, but we haven't actually integrated them well enough into the same places. The best places at the moment are on the West Antarctic Peninsula and the Scotia Arc. So we could make rapid progress there in developing a whole of system observing system. For the other parts, the Ross Sea and the East Antarctica Indian sector, we probably need to do a lot more work to coordinate activities. So how might we deal with this? We can use, I'm not going to go through this diagram in detail, but what it is that we can have some idea of the scenarios. We can use existing data sets such as satellite data and some of the foraging data and so on to start to get an idea about spatial and temporal variation. We can use simulation models to simulate spatial and temporal variation in the system, along with dynamic food web models. And we can start to then use those models as a foundation for testing different designs. And the map there is a possible ship-based design for observations that could coincide with satellite work as well as gliders and so on. So we can test those designs, and then the red bars that you see, the dots and bars, are meant to represent, out of that simulated system, what might your estimate of a particular variable look like and what might its variability look like. But because you know what the data actually was, you can then, which is the black line, you can then start to say, how good was that variable in telling you about what was really happening? And so that's one way of then starting to look at testing some of these designs, particularly for variables that we don't know much about. And then the bottom plot is simply to show, given different ways that we understand the system, given different kinds of designs, what's the performance of that particular variable in an overall design. That's a sort of process we started to discuss, but we haven't completed. But there are many groups around the world that have looked at these things that we can draw upon. So in the last minute, what I want to do is just to throw out there for discussion what some possible milestones might be from now, given where we've got to from the Rutgers meeting and the experience elsewhere. The map down the bottom is ultimately we would like a field implementation of the SOOS in relation to ecosystem variables. So how might we get there from here? We need to consolidate the existing activities. What variables do we already have? What are the standard methods that we have? What are the kinds of field programs that we might be employing already? Start to consolidate that. That's the sort of job of a task group. We need to start to test some of these other variables that we know are important, that there's some experience in some locations about how to do it, but we don't yet have standards and protocols, and we haven't thought about how that would be implemented around Antarctica. So we need to develop some coordinated activities to do that, to test those variables and whether or not they could be used. So using fieldwork, simulations, and also analyses. And I would suggest that a working group on ecosystem essential ocean variables could help make progress on that. So it's not to take all of the work, because the existing activities can already go through the process without having to go through a working group process. In 2018, ICE is going to hold a conference here in Hobart on assessing status and trends in Southern Ocean ecosystems. It's been supported by many SCAR working groups, and also it's been discussed in the SOOS steering committee from over the last year or so, and it's also been raised in Kamilar. And the aim of this particular workshop is there's four different aims. One is what would a design of the ecosystem observing system look like? What are the sorts of models and processes? How might you start to develop models to start to talk about the future? What methods might you use for assessing the status of ecosystems and reporting on them? And lastly, let's have a go at doing an assessment based on what we've got. So it's recognising that we're not waiting to start, we've started. It's about bringing it together. So maybe starting to work within the SOOS community to put forward a design in time for that workshop means that we have a good opportunity of having a discussion at a much more mature stage. And then lastly, it's good to have on the horizon when we can start doing all of this right round Antarctica. So we've got some opportunities for doing fieldwork in the West Antarctic Peninsula, and the Scotia Arc is already operational. But how about right round Antarctica? There's the year of polar projection, centred on 2018 for the atmosphere. Then maybe in 2020 we could follow that up with a circumantarctic benchmarking of the ecosystem. That would follow very nicely from the International Polar Year and the work that was done, the foundation work that was done then using the Census of Antarctic Marine Life. So maybe this is a way we can then take the ecosystem focus to the next step. So thank you very much. I'm over time, I'm sorry for that. I'm sure there'll be plenty of questions, but we'll have to wait till later. Thank you.
It's great, and I really appreciated the talk. There's just one comment I'd make on the focus on EOVs as necessarily a change indicator. There may be things that are very important for us to measure that by themselves are not great as an indicator of change. Chlorophyll A might be one. You know, it's very patchy in space and time, so actually detecting a trend in chlorophyll A from an in situ measurement may be difficult. But something that helps to calibrate ocean color is critical because it's the only way we get a global observation. The same might be said of an air sea flux mooring, for example. That measurement's essential primarily because it helps test the other products that are global in extent. The individual measurement is too local and maybe not sustained for a sufficiently long period to be useful as a way to detect changes. So just something for us to keep in mind, that it's not all about change. It's also about processes and understanding, and it's also about measurements that help us calibrate other measurements.
I agree with you.
Thank you.